Good morning, students. Today we're going to do just one problem for AP Precalc, and what I want to do is verify a trig identity. Here we've got a trig identity that could show up maybe on the on your AP exam in May. And verifying trig identities is where you're given an equation and you have to prove that the equation is true. So what we're going to do is work on one side of the equation, and using some manipulation and substitution using trig identities, we want to prove that the left-hand side is equal to the right-hand side. So when you're doing a trig identity problem, you're going to pick one side or the other and work just with that side until you can get it through, as I said, algebra manipulation and some substitutions to get it to match the other side of the equation. And typically what we want to do is start with the more complicated side. So I am going to start with the left-hand side. And I notice that I've got sines, tangents, cosecants, and cotangents. Now, oftentimes when you see that situation, a mixture of sine, cosine, and their reciprocals, like cosecant, mixed together with cotangent and tangent, what you want to do is get everything in terms of sine and cosine. I'm going to turn the reciprocal cosecant into a sine, and then I'm going to use the trig identities for tangent and cotangent, their ratio identities, to get those into terms of sine and cosine. So here's how the first step would look. I'm going to leave this as sine x. The tangent x, we're going to change that into sine over cosine. That's one of the trig identities that you need to have memorized for your exam in May. Cosecant is the reciprocal of sine, so I am going to change that to an equivalent form of 1 over sine, since sine and cosecant are reciprocals. And then the identity for cotangent, in terms of a ratio, is the ratio of cosine over sine, like that. Now, it's not immediately apparent why we would want to do that, right? Because it looks like we just made things more complex than less complex, right? I'm trying to go from a more complex left side to a less complex right side. But what this allows me to do is to consider when we have these what we call complex fractions, that is fractions within fractions. I've got these 4 smaller fractions within the overall larger fraction. What you want to do to simplify that is find what we would call the least common denominator between all 4 fractions that are present. And what I have here is I have a cosine, a 1, a sine, and a sine. And so if I ask myself, in that complex fraction with those 4 fractions, what's the LCD of those 4 inner fractions? The answer is sine times cosine. So the way that we get rid of these complex fractions is to multiply the top and the bottom of the fraction by that least common denominator. So what I'm going to do is I'm going to multiply sine x cosine x on the top and bottom of this fraction. Now that means that I'm really multiplying this left-hand side by something that's equal to the number 1. Or at least it simplifies to number 1, right? Sine x cosine over sine x cosine is 1, because those would divide out. But it suits my purposes, though, for the following reason. I'm going to distribute this multiplication to the terms on the top and the bottom. And when I do that, and I multiply the sine x right here times the sine x cosine, that will give me sine squared x cosine x. And then when I distribute it to this fraction, the cosines will divide out, and I'm left with sine squared x. Similarly, in the denominator, distributing here, the sine x's will cancel out and divide out, leaving me just cosine x. And then here, the sine x's will divide out. And so cosine over sine times sine cosine gives me a positive cosine squared x. All right. Now, you may be thinking, gosh, how was I supposed to know that this was the path I was supposed to take? Well, this is where practice comes in, right? These trig identities, you really only start seeing patterns of what you might want to try to get to simplifying one side to match the other by doing many, many problems. And you start to see kind of a trend. Like I said, the initial thing that I noticed was a mixture of sine with tangent and cotangent, oftentimes starting out by just converting everything to just sine and cosine is the first step. Another trick really that we learn as we do more of these identities is that when we have a complex fraction that was given to us or that we created by doing what we did in our first step, is that you want to multiply the top and the bottom by the least common denominator and then see what happens. It's not like you know what's the next step is going to be after that, but you do it and then see if there's something else that you can do. That's where we're at right now. We're like, okay, well, what does this get me? Right? We started at sine x plus tan x on the top and cosecant plus cotangent on the bottom, but now we are at this stage right here. And I notice from an algebra standpoint, there is something that I could do on the top and bottom to simplify, because there is a common factor in the numerator of sine squared. And you know from your algebra experience that when you're simplifying rational functions, that is ratios of functions, if you're going to simplify, you need to factor so that you could then possibly divide out common factors. So we will try to factor to see if we get a common factor between top and bottom. So if we pull out the GCF of sine squared x, that's going to leave us cosine x plus 1 right here. And then there's a common factor in the bottom of cosine x. And that leaves us 1 plus cosine x. Now remember, all along here, I'm bringing the right-hand side along, and the right-hand side was sine tangent. Okay, so I'm not touching that side. I'm trying to manipulate the left side to make it match the right side. Well, we're one step closer now, because what I notice is that we do have a common factor between the top and bottom here, which is cosine x plus 1. So these two are going to divide out. And what I'm left with then is the following equation. I have sine squared x over cosine x. And remember, our goal is to get that to look like the right-hand side. I am almost there now, because what I'm going to do, since I've got sine times sine on the top, I'm going to just rewrite it as sine x times sine x over cosine x, right? That is equivalent to sine squared over cosine. And then that allows me to see that I'm going to replace that sine over cosine with tangent. And so then my last step, and I'm done, is sine x times tan x. I've accomplished what I set out to do, which was to do some substitutions and some algebra manipulations to get the left side to look like the right side. So every step that I did was either substituting a trig identity, right? I did tangent for sine over cosine, cosecant 1 over sine. Then I did some algebra, right? Which was, let's multiply top and bottom by the least common denominator. That is a technique in algebra that we use when we have a complex fraction and we want to get rid of the complexity of the fraction and make it no fractions within the fraction. We multiply top and bottom by an LCD. Then the next step was, again, an algebra move, which was to factor out the common factor on both the top and bottom. And then we were able to divide out those common factors between top and bottom. And then just do a little bit of a manipulation here to rewrite this sine squared over cosine so that we could match the left and the right-hand side. Okay, now, will you see something that complicated on the AP exam? You know what? Probably not, but it is possible, right? It is possible on a free response question, for sure, that maybe they give you one of the harder parts of that free response is a very challenging trig verification. All right, and that is what a complicated one might look like. All right, I hope that helps, and I will see you all tomorrow. Take care.